Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. Today we are going to discuss an important topic of compiler designs. This is basically conversion of virtual registers into physical registers. So before knowing about this, we should first understand what is this virtual register and what are these physical registers. So virtual register is something which we need to consider while writing the code ourselves, because we need to optimize the code first, then its implementation. So writing the code, we take into consider some virtual registers which might not be actually existing in the system on which the program will run. So in that case, we use virtual registers, and they can be like infinitely large in number. We don't have an upper cap on the number of virtual registers we will take into account. But the scene changes when we talk about physical registers. Physical registers are the actual registers that are present in a computer system. And for those who might not know this, physical registers are quite expensive in price. So I would say that it is the most expensive part of the computer storage architecture, and since because of its like expensive nature, it is quite limited in number in a computer system. So we need to ensure that our code runs in such a way that least amount of physical registers are occupied, because other programs might also be using some registers while working while executing the same code which we are executing. So in order to keep that in mind, we will try to use as less physical registers as possible, right? So I want you guys to keep this in mind, and once we are like understanding what physical register and virtual registers are, we are good to go. So as I mentioned that there is an upper cap on the number of physical registers in a system. We cannot like expand it to large quantities like a lot, many 50, 60. There has to be a fixed number on which the physical registers reside, and beyond that we don't have the resources. Well, so now we come to the question itself. We are given to rewrite the following assembly code with virtual registers V1 to V6 using only 2 physical registers. As you can see that while writing the code, the programmer has used 6 virtual registers, but in reality the computer on which it will execute, there are only 2 physical registers, right? So in this case we need to insert spill code and describe how we are doing the same, right? So what is this spill code? So whenever we convert a program or an assembly code that uses virtual registers, we will have to like load some variables into the main memory, right? And then load back some memory locations into the registers. This we need to do a couple of times, maybe a number of times, because of the way the code is written, and we need to ensure that the spill cost is minimum. What I mean to say here is, we will look into this when we go into the problem in detail, but for now let's just understand that spill cost is like overhead of the computer system in executing a program. It has to repeatedly swap in variables between memory locations and registers, and this has to be minimized in order to improve the overall throughput of the system. So I hope I made sense. Now let's proceed on how we will convert this. So first of all, we will just number it from 1 to 7 so that we have an ease of locating which line we are currently at before executing anything. So I have numbered this. This is a small 7-liner code, and actual code will be quite large. I think it will be around 70 to 80 lines of code for a simple program, but for in our case there's just some basic multiplication and addition there, so it's only 7 lines of code. Perfect. So now we come to the next part. The first part will be making 3 lists. So the 3 lists will be as follows. First is a free list. Now what is this free list? Free list is basically the number of registers that are currently available to us. Now this specifically denotes the physical registers. This is the list of registers that are actually present in the system and are not being occupied by any variable as of now. Then we come to the next use table. So next use table contains the virtual register which we are given in the question. Then we are assigning that which physical registers are assigned to that virtual register, like each virtual registers will be assigned a physical register in order of its execution. So that physical register is written here, and then we are trying to since we have the code with ourselves, we will look for the next use. Suppose, let me come here. We can see that this virtual register V1 is being used in line number 4, right here. Before that V1 is not used. So we will say that the next use here will be 4. Why 4? Because the next use from this line is on the 4th line, right? I hope it makes sense. So this is the use of this is basically what is next use. So we will see that V1 has will be stored in P1 and has the next use 4 and 6. Now as you can see that it is used on line 4 as well as on line 6, right? So both these cases V1 is used, so we will have the next use 4 and 6. Perfect. Now we come to the next part. We have V2, and for V2 we will see how we will do this. Now I want you guys to just not look on this thing, right? Just focus on this. So in this part we write the next use 5. Now let's go back. V2 is used in, let me erase this. Okay, V2 is used in line number 5, right here, line number 5. So we write 5 there. So we have 5. Now for V3 we see that it is used in line number 4. So we write line number 4. Similarly, what we will do is for all the virtual registers we will write the next use. Perfect. Now we come to the next part. This is the third table which we need to create before actually beginning to assign physical registers to virtual registers. This is assignment order. Assignment order keeps the track of when which physical registers was assigned to which virtual register. Like in our case, first P1 will be assigned V1, then it will be assigned V5, then it will be assigned V6. So this order has to be kept in track, right? So this tracking of assignment is the assignment order, and correspondingly you can write the next use so that we have a track of when the next time when the physical registers will be needed in execution. Okay, so we need to create these 3 tables. I know that it might be a bit cumbersome to write it down at the first time, but with practice you will be able to write it down. Okay, now we come to the first step. The first step is assign all physical registers. Now since we are given a set of physical registers in this question, we will try to use all of the physical registers. So in our case we will assign all these registers. We are only having 2 physical registers, so only 2 virtual registers can be assigned. So let's begin with the first line of code, that is load X into V1. So then we are loading X into P1. P1 is the physical or actual registers which we have in the system. Okay, then we load y into P2. Similarly, as we proceed in this part, we need to update the free list. So once we are at the beginning of our program here, so we will having two physical registers free with us. Once we do that, then we will have only P2 left. And one step now means after loading y into P2, we have no physical register left with us. Okay, now we come to the second part or step second. And you can see that we need to keep a track of the line number as well. So if we go above, we see that we have crossed line number 2. Now we are in line number 3. So line 3, the step 2 will be swap in y, because P2 next use is greater than P1 next use. Okay, now what is this? Now the third line was load z into V3, but we do not have a physical registers to load the virtual register, right? So what we need to do? In this case, the rule says that we need to compare the next use, that when the next time in the code these physical registers will be used, and whichever stands greater, I mean whichever physical register comes later in time or later in the code, that we need to swap. Since in this case we can see that, let's go to line number 1. Line number 1 has next use at line number 4, so it will be 4, the next use, and line number 2 has next use at line number 5. So line 5 comes after line 4. So the physical register which will be engaged in performing operation for line 4 has to be kept intact, and we can swap the other physical register which comes later in the code. So to implement that, what we will do is we will swap the value of P2, and since we need to change the value of P2, we need to store the value of y into memory again. So this is spill. When we are storing this value which I had previously stored on the physical register P2, now we are storing it back into the memory at a different memory location. This is y. This is not equal to small y. This is a different memory location which our program will use in order to allocate a memory location and place the value of y there. Perfect. So now we see that P2 will store the value of y into a location named capital Y into the main memory, and then we will load z into P2, right? So then once we do that, so we are here like in line number 3, right? So we have loaded P2 z into P2 using this statement, load address of z into P2. Okay, now we come to the next step, that is step 3. We need to keep track of these tables as well. So as you can see that if we see the next use, first virtual register V1 was assigned P1 and the next use were 4 and 6. Then V2 was assigned P2 and the next use was 5. But since the next use of P2 was greater than P1 and we had no other physical register left, so what we did was we removed the physical register P2 from the virtual register V2. Okay, and this was the case of the next use table. And in the assignment order, what we will do is we will first have V2 in P2, right, as we had V1 for P1 and had the next use 4 and 6. Similarly, in P2 we have V2, and once we are done with that, we will store V3 and its next use, which is 4. Perfect. Now we are done with this. Now we have to again go and move to the next line of code. So in this part, line number 4, there is a next use of P1 but not for P2, so we use it to store the multiplication. Now if we go to the problem which we are given, we need to multiply V1 and V3. Okay, we have both of these registers with us. We have P1 for V1 and P2 for V3, but we now need to decide where we will store V4, because after the multiplication we again need to store the result in a physical register. We cannot just dump the register anywhere in the memory, so we need to store that. And in order to decide which register we will use, we will again use the next use. So we are in line 4, and the next use for P1, if we go, it is 6, right? It is 6. But for P2, if we see, P2 has the next use 4, and we are already standing at 4 and the multiplication has been performed. We are now looking to store the result in some physical register. So then there is only one option with us, to use P2. Why P2? Because we do not have any other physical register to hold the value. So then we store the value of P2 here, right? We have multiplication of P1 and P2 and store the value in P2 itself. Perfect. Now we come to the next part, which is line number 5. So in line number 5, we are trying to add V4 and V2 and storing the result in V5. So before we do that, I want to find what are the physical register and their assignment order now. So if we just go above, in here we will find that now we store V4 in P2, and as you can see that P2 is cut from V3 and we have it on P2, and its next use is 5. Okay, and in case of here as well, we will just use V4 and store V5. Okay, so that we did, and now we are here. So now we need to store X in main memory and now check the next use of P1 and P2. So P1 has the next use 6 as it had from beginning itself, and P2 has next use 5. So X was swapped. So now if we go above, we will see that V4 was stored in P2, and V2 we need to load it from main memory and we need to store it somewhere, right? So what we will do is we will just store it in P1. Why P1? Because its next use is greater than P2. So we store value of X from P1 into the main memory first, and then load the value of Y into P1. Remember that what is Y? Y is what we had stored previously. It is the value of V2. So that we are loading into P1. And why P1? Because its next use is greater than the next use of P2. Perfect. So now we are having another assignment. So what we will do is we will just write it here that P1 has the next value of V5 and its next use is 6. And if we just go here, V5 and 6. Okay. Now we come to this part. We were in line 5. Now we need to store the value of V5, right? So once there is no further use of P1 or P2, since like we are in line 5, right? And the value of P1 here is on 5 itself, that next use is 5, and P2 also has next use 5. So we can either use either of them to store the result. We can either use P1 here or P2, it doesn't make a difference because both of them have equal next use. So we store the value in P1, then we move to the next line. And if we just see here that we are storing the value of V5 in P1 in 6 and V5 in 6, right? So that is what we are doing. And I think I missed some part here, because before this we will have V2, P1 and 5, right? Before this I had made a mistake, it will be V2 and 5. Okay, now what we will do is now we need to have the next line, which is add V5 and V1 and store it in V6. So V5 we already have in P1, and V1 we need to calculate, that is the value of X which we had stored previously. So what we will do is, we will since P2 has no next use, right, it is already on 5 and we have succeeded that, so we can use it to load X. So load X into P2. Then we can choose either P1 or P2 because both of them have the same next use, that is 6. So we can either choose any one of them. We will choose P1 for now. So the value of V6 is stored here. So we will write that same in both these tables, that is P1 has V6 and its next use is 7. Similarly here. And once we are done with that, we will finally go to the next line, which is store the value of P1 into Z, just as what we have here, that we are storing the value of V6 into Z. So that's been it. I hope I was able to make you understand how we translate virtual registers into physical registers and how we use next use to optimize this assignment so that the least spill occurs. We need to make sure that basically when we are executing a program, spill cost is the minimum, and to ensure that we use the concept of next use and make these tables and execute in such a manner that the number of times we are swapping the memory in and out of registers is minimum. If you still have any doubt left or any queries, then feel free to reach out in the comment section below. And if you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.